Now that you've learned a great deal about the new semantic elements that are in HTML5, you've done basically the equivalent of eating your broccoli. You've eaten the proper nutritious semantic goodness, and now it's time for some juicy vector graphics. Some of these bits and pieces that I know you've probably seen demos about, we're going to actually code a little bit ourselves. Where does HTML5's native vector graphics come from? Well, it comes from two sources. The first is SVG, which is W3C's vector graphic markup language. W3C has been developing SVG for quite some time. It's the result of years of collaboration and working together between companies like Adobe, with their experience long-term in vector formats such as PDF, PostScript, Display PostScript, all of that, and Microsoft as well, with their experience doing vector graphics and their own attempts at an XML-based vector graphics language like VML. So over years of experience, they came together, they developed SVG, it's based on XML, and it actually has some degree of support, which is external images. And external images that are in SVG are used widely throughout Wikipedia. I have an example of one of these here for you that shows you a symbol that's used actually on the article for science on Wikipedia. SVG is used when you want to create a graphic, a single graphic that scales to arbitrary resolution. In many cases, a lot of folks use things like Flash as well to embed graphics, but these days most browsers support SVG, so more and more folks are using SVG to embed vector graphics into their markup. The other piece of the vector graphics puzzle for HTML5 is Canvas. And this is quite exciting because what happened here was Apple decided to use HTML and CSS to support the little applications that they have on their platform for their dashboard layer. And making these applications based on web standards was one of the first times that a platform vendor has really done so honestly and heartedly. And one of the limitations they ran up against was that there was no good drawing language in HTML. So they invented the Canvas element, which so many other browser vendors found useful, that was quickly implemented in Firefox and Opera as well. And so all these companies already working together, like we talked about in the background history section, on the web applications, decided to incorporate Canvas into HTML5. So let's take a look at a really simple Canvas example. Here's a simple example of two overlapping squares. So we're going to do the time-honored tradition. We're going to view source, go ahead and copy that. Yeah, it is that small an example. And switch to our text editor, paste it in, save it, go ahead and drag it in, and see if that works. Yep, still works for us, great. So let's go ahead in here and take a look at what's going on. Well, we've got a title. Everyone understands what a title works like. We've also got the script here. The script tag is what's doing the work. Okay, we've got a drawing function that we keep looking down here, body, on load, it calls the draw function. All right, what's the draw function doing? Let's step through it. The first thing it does is it calls document.getElementById and looks for the element called example1 with the ID example1. If we take a look at the body, there's one element, canvas, with that ID. It's got a width and it's got a height. And it has fallback text as well, which anytime you have image or graphics, you ought to have some form of fallback content. In this case, it just says two overlapping squares. All right, so we've gotten the canvas element. If canvas.getContext, what's this doing? This is basically calling on the method on the canvas object that got retrieved from getElementById to see if that method even exists. If it does exist, then it calls canvas.getContext with an actual parameter. What's it really doing here? What it's just doing is it's testing to see if the browser supports Canvas. If the browser supports Canvas, then this will return a non-zero defined result. We'll continue the code. But in a browser like IE, it'll return undefined, and therefore we won't execute any of this code. So in a browser like WebKit, we call canvas.getContext. We ask for the 2D context. There's some work on a 3D context as well, but for now, we're just going to talk about the 2D context because that's what's ready and usable. We assign that to a variable. We set its fill style to an RGB color. Then we call fillRect with top left, and dimensions, and then we call another fill style. We change the fill style color to another color with a little bit of an alpha channel, so we get some transparency. And then we call another fill rect, a slightly different location, but again, the same size, same width and height, a square. And the end result, as you see, is a square, two overlapping squares. Let's go ahead and see if we can modify this code, which is one of the best ways to learn when you copy and paste an example. Let's just go ahead and copy and paste that and go in here, and we've already got a red and a green, so why don't we create a blue? Blue, simple blue, be 0, 0, 255. And let's make this 50% opaque so that it's still somewhat transparent. And following this pattern that the other squares are doing, let's put this at 96, 96, and keep it the same width and height. Save. All right, let's go to our browser, reload. Wow, doesn't that look pretty? We just added another square. That didn't take much work at all. And that's one of the beauties of this copy and paste view source coding style. You can take a simple example, modify it, get some effect immediately, and have that satisfaction. The great thing is, I'm going to walk you through some of the other browsers here and show you that in Firefox, looks about the same. Opera looks about the same. Great. So what we've just demonstrated, oh look, one more browser, Google Chrome. How about that one? Same result. So what you're seeing here is that we've actually got consistent support for Canvas across major browsers. In fact, all browsers except IE, and I'll get to that later. If you want to read more about how the Canvas element works, how to expand upon it, other drawing primitives, I recommend that you check out the excellent tutorials that are online, starting with the Mozilla basic usage of the Canvas element tutorial. So how far can we take the Canvas element, right? When people first got the opportunity to create new web applications, what did they do? Well, anyone ever used that old application on Windows, MS Paint? Yeah, I can see what you're thinking already. Let's take a look at what happened when a web application developer decided, hey, let's see if we can actually create something that looks like MS Paint. And this is Canvas Paint. You just go to canvaspaint.org and give it a shot, try some different colors, and you find, oh my goodness, somebody has actually coded up an entire painting program in HTML5, CSS, and JavaScript using the Canvas element. And then sometimes you run into limitations. That's important to note. Not all browsers support all Canvas operations. So when you do code a Canvas graphics demonstration or graphics feature into your site, you still need to test across browsers, and that's an important point. It's an awesome, excellent feature to use to create some amazing effects. It still requires you to test cross-browser. Of course, what graphics discussion would be complete without an exploration of what games were possible? In this case, we've created this Laseroids. Someone's created this Laseroids demonstration that uses Canvas and JavaScript and events and their own voice, presumably, to actually make a game out of it. Somehow I seem to have lost all the asteroids. Well, if there's no asteroids, there's no problem, right? I guess that's how you win the game. All right. So as you can see, there's a lot of opportunities with Canvas, a lot of things you can do. The challenges. Big one with SVG. SVG is a separate file, works fairly well in browsers, across browsers even. One thing that HTML5 introduces is the ability to embed an SVG graphic, since it is just XML, natively into your HTML document. This is actually not well implemented. I've tested across numerous browsers. I haven't found very good support at all. Ironically, support for this feature of HTML5 is promised in IE9. However, without having some degree of cross-browser support, I wouldn't bother with trying to make this work until we see something different. Maybe in a year or so things will change. With Canvas, a lot of opportunities, but there's still a lot of challenges. So I need to be really upfront with you. As I pointed out before, you need to test cross-browser to make sure that the different Canvas operations you use actually do work in the browsers that you want to support. which is hopefully all the browsers. First of all, it's implemented everywhere but IE. It's a big challenge. What does that mean? Well, for websites on the traditional web, the open web, you want to make sure your websites work across all browsers. There are some JavaScript libraries to try and emulate parts of Canvas in features that are built into IE, such as VML, and those are referenced in the various tutorials. However, it's still enough of a challenge that I recommend, well, Canvas requires good design for fallback. And that means that while I showed you a simple overlapping two squares example, I didn't even remember to update the fallback to 3 overlapping squares. It's a big challenge, and this is just a simple example. For something like that Asteroids game or MS Paint, how do you present an alternative that makes any sense? I don't know. And especially if someone is not visually sighted, how would they access your Canvas content? And that's one of the really big challenges about Canvas. The accessibility techniques for how to use Canvas and do so accessibly while providing an alternate representation for information are still being developed. I'm not saying it's not possible. I'm just saying that it's not something that's very well understood right now. There aren't a lot of real-world examples. And if you look at most of the really cool whiz-bang Canvas demos, there's almost no fallback at all, if any. Never mind one that's actually accessible. So my recommendation for now is go ahead and use Canvas, but only for decorative images. Canvas is kind of at the point where rounded borders was maybe, say, about a year ago, and that is that you should only be really using it for decorative reasons in some browsers. In CSS, rounded corners have finally made it to the point where there is good cross-browser support, and it is promised in the next version of IE, so we're getting to the point where we can start to potentially depend on it. When that happens with Canvas, we'll be able to take those steps forward as well. So go ahead and build Canvas into decorative images, or experiments here and there, build your web applications, but I wouldn't rely on it for any sort of core functionality that you want to work across all browsers, because it's simply not quite there yet.